welcome back, and now let's talk about horizontal stretching and shrinking. So in this case here, again, we start with the parent function y equals f of x, and a is a positive real number. And so in this case, again, if a is greater than 1, then in this case what we have is the graph of f of a times x, so now we're multiplying x by a factor a, right? So it's inside the function. So this is going to be in the horizontal direction. And so again, if a is greater than 1, then the graph of y equals f of a times x is the graph of f of x, but shrunk horizontally by a factor of 1 over a. Okay? So if a is greater than 1, it results in a horizontal shrinking. Okay? So opposite of what we saw with the vertical, right? Again, not what we might think automatically or assume if we didn't know, right? So that's the horizontal shrinking. Now, what about the horizontal stretching? That happens if a is between 0 and 1. If a is between 0 and 1, then the graph of y equals, f of a times x, right? So again, if a is between 0 and 1, then the graph of y equals f of a times x, so again, we're inside the function, is the graph of f of x stretched horizontally by a factor of 1 over a. So in this case here, a point on f of x, x comma y, will become x divided by a comma y on the graph of, did that again. The graph of y equals f of a times x. Okay? So this is what we mean by a horizontal shrinking or stretching. Okay? Now we'll do some examples.